The notes for this lesson are the notes that you're going to be using for both days that I'm not going to be here. So these are the notes for properties of exponents. Now, we have talked about exponents. I'm sure you have seen them, and as soon as we start reviewing them, I'm sure that you're going to remember them from your previous classes. So there's a rule that says what happens when we have a 0 as an exponent. So the rule for that says that x to the 0 will be 1, 5 to the 0 will be 1. So anything to the 0 power is 1. Second rule is we're not allowed to have a negative exponent. What happens when a negative exponent ends up in your answer? So let's say we had x to the negative n. We would have to rewrite this as 1 over x to the n. Let's say we had 2 to the negative 3. This would end up as 1 over 2 to the third. So we rewrite it as a fraction, and when it goes to the bottom, it becomes a positive. So right now we're just writing the rules, but in a little bit we're going to see examples of all of them being used. When we are multiplying the same base, for example, if I have xm times xn, you end up adding your exponents. So this becomes xm plus n. Next rule, when we divide the same base, we end up subtraction. So let's say we had x to the power of m divided by x to the power of n. You actually have to subtract the exponents. In a little bit, once again, we're going to see those with numbers. And the last rule is when there is multiplication of exponents. So what happens when we have a multiplication of exponents? So what does that mean? When there's an exponent here and an exponent there, you have to multiply them. And that's what's going to give you the answer. Now, your assignment will take 2 days because it is a total of 87 problems. It's all based on these 5 rules. So we're going to start covering a lot of examples. So we're going to practice. That's basically what it's going to be. Practice. So let's say that we have y to the 6th times y to the 4th. So the power of y is 6, the power of y is 4. They both have the same base. Multiplication, rule 3 says that when you multiply, you add your exponents. So this becomes 6 plus 4, which is y to the 10th. And that would be your final answer. Let's see another problem. Let's say we had 3x squared y to the 5th times negative 2x y squared. So if we see we're multiplying this front part times the second one, we end up multiplying the 3 and the negative 2, and we have to add the exponents. This has a power of 1. What is 2 plus 1? And then we have to add the powers of y, which is 5 and 2, This becomes a negative 6, 2 and 1 becomes a 3, y to the 7th. So we do multiply the big numbers, but the exponents, we have to add them when there is multiplication. Now, let's say we had a problem like this one. 5m to the 4th, and it has an exponent outside. So in a problem here, please remember that you do multiply these, but keep in mind that the 5 has an exponent of 1. So this 2, you have to multiply times that one and that one. So this becomes 5 squared, and m 2 times 4. Now 5 squared is 25, 2 times 4 is 8. Now let's look at this one. 5 to the 0 power, w to the 3rd of a negative 2nd. Now once again, the power outside belongs to everything inside. So it's 2 times 0 and 2 times a positive 3. And it's negative 2 outside. So 0 times a negative 2 and 3 times a negative 2. 0 times a negative 2 is just 0. W 3 times a negative 2 is a negative 6. Now, rule 1 says anything to the 0 power is 1. So this here becomes a 1. That is still w to the negative 6. But then rule 2 says, hey, negative exponents are not allowed. So I have to rewrite this as 1 over w to the positive 6. Now, let's say you have a problem a simple one, just something like this. Is a negative exponent allowed? No. So this would become 1 over 4 to the positive 3. But please keep in mind, 4 to the 3rd power is 164. It's a 64. So it's 1 over 64. So if you could simplify, please do so the way we did here. The 5 squared became 25. The 4 to the 3rd becomes a 64. Let's say I have 3 over 7 to the negative 2nd power. Now, that power outside belongs to the exponent of 1 of the 3 and also the exponent of 7. So this becomes 3 to the negative 2nd over 7 to the negative 2nd. So they both have a power of negative. In a problem like this goes to the top and this goes to the bottom. So this becomes 7 squared over 3 squared. Now, what is 7 squared? 49. What is 3 squared? 9. That's your answer. So that's just when you have two little numbers. Let's look at this one. Let's say we had 3x over 5y to the negative 3rd. So once again, the exponent belongs to everything inside. So there's a 1 here, a 1 there, a 1 there, and a 1 there. So it belongs to that one, times that one, times that one, times that one. So this problem becomes 3 to the negative 3, x to the negative 3, 5 to the negative 3, y to the negative 3. They all have negative exponents. So we're going to have to move both of these to the bottom and both of these to the top. And that's the only way that we can make them positive exponents. So this becomes 5 to the third, y to the third, over 3 to the third, x to the third. But because we could simplify the 5 to the third, and in case you don't know it, this is where you use the calculator. 5 times 5 is 25. 25 times 5 is 125 y to the third over 27x to the third. Now, what happens when we have a problem 5x to the negative 7, y to the 0? A problem like this. So, can we combine anything? No. But we should know that, hey, this y to the 0 is actually a 1. So, having a 1 there is not going to change anything. It's 1 times 5 is still 5. But there is something wrong with this. Who has a negative exponent? This guy. So we're going to have to make this a fraction, and it becomes 5 over y to the positive 7th power. Now, what happens if I end up with 7x to the negative third over 3y squared? So, what is the only thing that is wrong here? Can't do anything with the 7, but that x has a negative exponent. So, because it has a negative exponent, we have to move it to the bottom. Is there anything in the bottom that should be moved to the top? Do any of those have a negative exponent? No. So then this is just 7 over 3x cubed y squared. Now, what happens when your bases are all the same? Let's say I had 7 to the third times 7 to the negative second times 7 to the fifth. Now, are all my bases the same? Base 7, base 7, base 7? Yes. So you add your exponents. So these problems look different, but it's the same rules. Plus a negative 5, plus a negative 2, plus a 5. Now, 3 plus 5 is 8. 8 minus 2 is 6. You could plug this into the calculator, or just, actually, the ones, these are for problems 21 through 26. We're just rewriting them, leave the answer like this. Rewrite it as one base. Looking at example K, let's look into a problem like this. 2p to the third, q to the negative second, r to the 7, 6, p to the 6th, q to the negative 5th, r to the negative 2nd. So it's a big crazy problem, I get it. So copy that down. But now the question, and I know we've talked about a lot of negative numbers, moving them from the top to the bottom, But the reason we were moving them before anything was because they couldn't be combined. We didn't have the same base on top and the bottom. But in this case, we do. So what do we do when we have the same base on top and the bottom? Well, first we need to do work with the fourth rule that says division means subtraction. Now, just like in multiplication, you divide the big numbers, well, just in division, we have to simplify 2 over 6. 2 over 6 reduces to 1/3. Now, everything we're going to write it on top, and then later, if the final answer is negative, that's when we move it to the bottom. So I have a base p, and the p has an exponent of 3 minus 6. Once again, why are we doing subtraction? Because it's division. We have q, negative 2 minus a negative 5. We have r, 7 minus a negative 2. So it's always going to be subtraction depending on the situation. Sometimes we have a double negative, like here. 2 negatives becomes a positive. 2 negatives becomes a positive. So when I redo this, this becomes 1 over 3, and I'm still writing everything on top still. 3 minus 6 is p to the negative 3rd. Negative 2 plus 5, that's a q to the positive 3. And the 7 plus 2 is a positive 9. So the only thing that it's in the wrong place would be the p to the power of negative 3. So we move that to the bottom. Everything else stays the same. And that right there would be your final answer. Let's try one more similar to this. Let's say we have a negative 24 m to the negative 5th n to the 4th over 8 m to the 3rd n to the negative 1. So same type of problem. We have division, we have positive and negative exponents, we have the same base on top, same base in the bottom. So we take care of the division part. Negative 24 divided by 8 is a negative 3. We subtract our exponents, negative 5 minus a positive 3. And then we have 4 minus a negative 1. So this continues to be a negative 3. We subtract negative 5 minus 3. That becomes a power of negative 8. 2 negatives become a positive. 4 plus 1 would be a 5. Now, we only look at negative exponents. This is the only one. The numbers could be negative, but not your exponent. So when I rewrite this, there's a negative 3 on top, the n to the 5th power. In the bottom, we're moving the m to the 8th. Example m. So let's say we had a problem, something like this. That should be an X, sorry. So let's say we had a problem like this, and it just became kind of crazy. Now, this negative 1 belongs to everything. Okay? So the first part, this is going to stay the same. This is going to stay the same. We can't do anything right now. You have to distribute that, so it becomes 6 to the negative 1, x to the positive 1, because a negative times a negative becomes a positive, and y to the negative 3. Now, please remember that we get to multiply numbers. In this case, this cannot be multiplied, the 6, because it has a negative exponent. We will multiply it once we move it to the bottom. But on top, what I have is 2 times a negative 3, which is a negative 6. I'm going to add my exponents. Please remember the exponent here of x is 1. So I have x 3 plus 1 plus this other one. And then I have y 5 plus a negative 2 plus a negative 3. And don't forget that we still have that 6 to the negative 1 that we haven't used, but eventually it's going to go to the bottom. So this becomes negative 6x to the 3, 4, 5, y to the 5 minus 2, 3 minus 3 is 0. This guy, because it has a negative exponent, I'm going to rewrite it in the bottom as 6 to the 1 power. So this here, y to the 0 is still 1. So this is just negative 5x to the 5th over a 6. Now, all that craziness is going to simplify to just one little thing. 6 divided by 6 is 1, but there's a negative. You could put the 1 if you want to or not, x to the 5th. That's what the final answer would be. I don't think any of your assignment are that crazy, but just for you to kind of see them there. Now, let's say that I have x to the 4th and a 1/3 outside. So it's just a rule. I know there's a fraction. It doesn't make it any different. What do you do when we have an exponent there and an exponent there? According to the last rule, you just multiply them. So this becomes x 4 over 3. And that would be your final answer. So what happens if we have x to the 5/3 times 3? The 3 outside. So 5 times 3 is 15 over 3, because remember this goes over 1, so it's the top times the top, bottom times the bottom. So 15 over 3 reduces to the power of 5. Problems are not that bad, I promise. Problem P, let's say we had x to the squared negative 5 times x to the 3rd negative 4. So let's say we had a problem like that. So yes, there's negative, but because there's next to something, we take care of that first. So we multiply them. This becomes x to the negative 10 times x to the negative 12. Because it is a multiplication between them, we do have to add. So this becomes negative 10 plus a negative 12, which becomes x to the negative 22nd when we add those. Because there is a negative exponent, it becomes 1 over x to the 22nd. Now, example Q. Let's say we had z, y to the negative third, z to the sixth, a negative 1 here, y to the negative fifth. Negative 1 and negative 3. So first of all, this negative distributes to all this. So this becomes z, y to the positive 3, z to the negative 6, and y to the negative 5. Now, they're all being multiplied. We see negatives, we might freak out. But multiplication leads to us adding the exponent. So there's an exponent of 1 here. So we have z1 plus negative 6 times y, 3 plus a negative 5. Now, 1 plus a negative 6 becomes a negative 5. 3 plus a negative 5 becomes a negative 2. They both have a negative exponent, so both of those have to be moved to the bottom. So this becomes y squared, z to the fifth. I just wrote them in order. If you would have put z to the fifth times y squared, it would have been just fine. Now the very last part of the notes, we're going to be finding areas of shapes. So for the last part of the notes, we need to find the area, and it goes in reference to your last 4 problems. Find the area of each so we're on Q, R. Let's say they gave you a rectangle, and they told you this was 5x squared plus 3, and this is 2x squared. Now, how do we find the area of a rectangle? The formula is L times W. So all you have to do is multiply this. So we have 2x squared times 5x squared plus 3. Now we're going to distribute, basically. So 2x squared times 5x squared becomes 10x. Because it's multiplication, we add our exponent, so 2 plus 2 is 4. 2x squared times 3 becomes 6x squared. That's how simple those are. Now, when you have a parallelogram, it's the same rule. Now, you have a height. Let's say the height is 2x squared, and you have your base. So the formula is the same, it's just they use different notation. I mean, you're basically doing the same thing. So the area of a parallelogram, they say it's base times height. This is the base, that's your height. We're still multiplying. 2x squared times 5x plus 6. What's 2x squared plus times 5? That becomes a 10x cubed. 2x squared times 6, 12x squared. You can't combine those because one's cubed and one is squared, and that's it. Example T. What happens if they give you a triangle? Now the area of a triangle is base times height divided by 2. So let's say that your height is going to be 2x. I'm just going to keep using the same numbers. 2x squared. The base of it, let's just change that a little bit, would be 6x squared minus 5. So we do the same thing. Set it up. Base times height. You multiply the top. Just at the very end, we're going to have to divide by 2. So we take care of the top. 2x squared times 6x, 12x squared. 2x squared times a negative 5, negative 10. Oh, and this was supposed to be a cubed. This one should be a square. All this divided by 2. So 2x times 6x, that becomes 12x cubed. 2x squared minus times a negative 5 becomes a negative 10. We have to divide both by 2. 12 divided by 2, 6x cubed. 10 divided by 2 is a 5x squared. And that right there would be your final answer. And the last one, U. They're going to give you a square. So please know a square, all sides are the same, 90 degrees, and they're just going to give you one. Let's say they give you 4x to the third. Now, how do you find the area of a square? It is s squared or L times W, whichever way you want to see it. So this becomes 4x cubed times 4x cubed. 4 times 4, 16. X cubed times an x cubed. We have to add those, so that it becomes x to the 6. Now these are your notes. I will be sending you the link in case you need to see the notes again, the explanation, have them out, work on the assignment. You have 2 days to finish it and turn it in.